Hello everyone, welcome to Abhijeet Codes. So till now we have seen how to insert the elements at certain positions in a linked list. So if you have not watched those videos, I would suggest please go back and watch them. In this video, we are going to see how to delete the first node of a linked list. Okay, let's suppose we have got a linked list like this. There are few nodes connected with links. Okay, and last is connected to null. Let them be 10, 20, 30, and 40. So here we want to delete the head node of the list. So this is the head node. Okay, so if we delete this head node, this should become our next head. Okay, because we are deleting it from the beginning only. So now our head will become the second element. If there is only one element, then our head will become null. Okay, suppose there was just one element like this. So when we delete it, our head will become null. Okay, so what we need to do this, we will first, let's make a temp variable. Okay, temp, and in this we'll store head arrow next and head dot next for Java. Okay, now in Java, the automatic graphic lesson is there, but in C++, we need to explicitly delete this node. So we'll do delete head. Okay, and at the end, we will simply return temp as our new head. Okay, so what we did, we stored the next of head, then freed up the memory for head. So this will be deleted and we return the temp, that means heads next. So this is the simple code to delete the first element of a linked list. Okay. Suppose if you want to delete the last element. Okay. So how will you do this? So for deleting the last element, you would need the access of this node. Okay. So we will initialize some current variable. We will move this variable until. Okay, so this is a new topic. So let me make a separate list. So how to delete a node at the end of singly linked list. Okay, so let's make a node list, and its next will be null 10, 20, 30, and 40. So the code for deleting from the front is this much only. Okay, so for deleting at the last, we will make a pointer current. We will move this pointer until this current's next is not null. Okay, because we want our current to reach here. Okay, so we'll do while, first of all we'll check while current not equals null, and if current is not null, then currents next should also be not equal to null. Okay, let me put this. Okay, so this both conditions should be satisfied. So what happens if there are only one element? So we need to check for that also. So if there is only one element, so if we will check at the beginning only, if head equals, it is also possible that there are no elements. So we'll check if head equals null or heads next equals null. So if any of these two conditions are true, we'll simply return null. Okay, because if there are no elements or there is only one element, so we need to return null. This will also be included in the above code. Okay, deletion from the head we also included there. So this will be added before here. Then now we will keep our current moving. So current will be simply current arrow next and current dot next in Java. So current will move till current's next will this is this and next is not null. Whenever this becomes true, we'll stop. So it will stop when we come here. So what the initial current will be? Current will initially be equal to head. Okay. So this is head. So let's do a diagram. So initially current will be pointing here. Then we will check if current is not equal to null, which is true, and current's next is also not equal to null. So current next it is 20 and it is also not equal to null. So current will move from here to here. Okay. So now the current will move to 20. Next we'll check 20 or 20 is next is not null. It is true. So now the current will move to 30. And in next step we'll check if current equal to null, current next not null. Okay, so this is true. So current is not null and current's next is not null. So this is true. So the current will move here. Okay. So we'll also keep a note of previous. So we'll declare some previous variable and at each step we'll do previous equals current. So after all this loop ending, our previous will be pointing here. So previous will be a node previous to current. Okay. So at the beginning, previous will be, let's suppose, null. It will check if 10 or 10's next is not null. Okay. So previous will become current, that is head. So at first run, our previous will become head and this current will be pointing to 20 and head is 10. Next, this will be 20 and it will be pointing 30. Next, it will be 30 and this will be 40. And after this, current next is null. Okay, so this loop will stop here only. So now what we need to do is we need to first make the previous next equal to null. Okay, so now this 30's next is null, there is no link to 40. And then if you are coding in C++, we need to free this memory. So we'll do delete current because current is pointing at 40 only. And at the last we will do return head because head will not change. Head will only change when there is only one element, and in this case head will become null, and for the rest of the cases it will be Yes, only. And also here we are deleting the last node. So that's that. Okay. This is the code. So pause your screen and see the code. Okay. So let's discuss the time complexity for this code. So time complexity will be big O of n because we need to traverse the whole linked list to get the end of the linked list. Okay. And the space complexity will be big O of 1. So if you watched the video till here, I would like you to subscribe the channel and comment your thoughts if you have any questions. Thank you and see you in the next video.